Hey everyone! In this video, I'm going to show you how to compute the mean and standard deviation of a probability distribution using an example personal to me, my Wordle scores. So Wordle's a game that I play. I've played it 259 times, and the goal is to guess a 5-letter word by guessing letters on the keyboard. And sometimes you guess the correct letter in the correct spot, and sometimes you don't. And you have only 6 tries to guess the word before you lose. So you can tell that I've won 96% of the time. I did the math and I have won the game 249 times and I've lost 10 times. I just did the subtraction there. You can see that I have never guessed the word on the first try, which is kind of a bummer. Maybe someday. 5 times I've guessed the word on the second try, which is awesome. But usually, because 89 times out of every time that I've played, I have taken 4 tries to guess the word, and sometimes it takes me longer, and sometimes it takes me longer than 6, but they're not here, and that's called a loss. So these are all my distributions of winnings of the game. So every time I see this graph, I think of a probability distribution with discrete outcomes. 1, 2, 3, 4, 5, and 6, and then I have a number of times that I've won. Well, I can take that and I can turn it into a probability distribution by using the count in each column and then, or row, and then dividing by a grand total. So it's kind of tricky to see this distribution here because it's going sideways. So I made a graph, and if I tip it sideways, you can see a nice little histogram. And to compute the probabilities of winning the game in 1 guess, 2, 3, 4, 5, or 6 guesses, I'm actually going to use sheets to compute this probability for me. So before I can compute a mean, I need to have a probability of each outcome. So I'm going to go into sheets here, and I'm going to create a column for all of the guesses that it takes. So I can win the game in 1 guess, 2, 3, 4, 5, or 6 guesses. So actually, if I label this as x equals number of guesses to win the game, I have written down my variable here. And then I'm going to start a second column for the probability of x. So I've never won the game in the first try, so I know that that probability is 0. And then I'm going to go to each of the other columns and then add up and divide. So 5 times, it's taken me 2 guesses. So equals 5 divided by 249. And then I'm going to go to all the other columns also. So 50 and 89. And then 70 and 35. Okay. So this here is a probability distribution because it shows all of the possible outcomes and then the associated probabilities. All of these probabilities are between 0 and 1. 0 is a possible number. You don't have to be larger than 0 or less than 1. It can be exactly equal. And then all of these probabilities should add up to 1. Now, if I highlight all of these probabilities and go down and look in the corner here of my spreadsheet, the sum is 1, which is great. That's what I want. It also doesn't matter the number of decimal places. I can make it look a little cleaner by decreasing the number of decimal places. There we go. I changed it, so now it's just 2 decimal places. And down below, the sum is still 1. You might get a little rounding error, but usually these should add up to about 1 because this is all you have. These are all the possible outcomes, and these are all of the long-run probabilities It's like your whole world is shown here in this table. Nothing is going to be missing. So this isn't a sample, this is a population because it's long run probabilities of this thing happening. Okay, so let's compute the mean of this probability distribution. We can tell if we look at this graph, the green bar shows me the mode class, so most of the time I'm winning the game in 4 tries, but sometimes it takes me a little longer. Occasionally I'm lucky and I can guess the word in a few tries. So if we try to think about an average, I might think it's maybe closer 4 to 5 range, so maybe like 4.5, because this bar is taller, it's going to pull the average closer to it, and 1 and 2 are very unlikely number of guesses. So the average is definitely not going to be a low number. To compute the average, we're going to use the applet called Staplet. So staplet.com is the website. And we're going to go down to discrete random variables. And this is discrete because my outcomes are 1, 2, 3, 4, 5, and 6. You can count those on your fingers. It's not like I could have one in 1.1 games or 1.1 tries or 1.00023 tries. It is a finger counting sort of outcome. So discrete random variable. I can put my variable name right here. So I'm just going to copy it from my spreadsheet. And I'm doing this because it gives me a really nice label on my graph that's going to show up in a moment. All right, so I could win Wordle in 1 guess, 2 guesses. I need to add some more rows. 3 guesses, I could win in 4 guesses, 5 or 6. So again, this is the number of guesses to win the game, so it's going to max out at 6. I mean, this is only considering winnings, not my losses. And then I'll take my probabilities from over here in my spreadsheet. The only reason I needed this spreadsheet is because my picture didn't tell me probabilities or percentages. I had to do the math myself. And you don't have to use a spreadsheet. You could use a calculator to get the same answer. So we have 0 and 0.02. Let's just keep filling in this table. 0.20, 0.36. And then 28 and 14. Okay, so I have my variable name, which just gives me a nice label later on. I have all my values. I have all my probabilities. So not percents, not counts. It has to be a number from 0 to 1. And then I click Begin Analysis. Okay, so in this output, I have a graph of my distribution. So 1, even though there was nothing there, it's still going to be put into my graph because it's still a possible outcome, even though there's nothing there. So we definitely keep an empty column in this graph. And then 2, 3, 4, 5, and 6. And here's my label, X equals number of guesses to win the game. If you hover over one of the bars, it will tell you with some really nice notation, like the probability that X is equal to 6 is 14%. So the probability that it takes me 6 guesses to win Wordle is 14%, or 0.14. And if you need to add up any of these outcomes, because they're discrete, there's no overlap, you can't win in 2 times and 3 times on the same day, it's one or the other, you can just add up probabilities. And down below, easy peasy, here is the mean and the standard deviation of the number of guesses for me to win the game. So yeah, the mean was a little bit more than 4 because of that 5 and 6. It's 4.32, and here's the standard deviation of the number of guesses that it takes me to win the game. One thing that you might find useful is the number of decimal places here in the answers. You may need to adjust the rounding or color or percentage preferences. So if you click on that, the rounding of numbers, you can change this to from round to as many as 4 decimal places. You can change that to round always round to 4 decimal places. So if you need that precision, no matter what, you can change this option here. When you do, I'm going to say always round to 4. I'm going to click done. What you'll need to do is click on begin analysis again. So it didn't automatically change all those decimal places. You just have to click that button, and there you go. You can see how there's always 4 decimal places in this answer. And also your axis labels changed. That's maybe not necessary, but depending on your homework system, you might need all those extra decimal places. So there we go. We have computed the mean and standard deviation of a discrete probability distribution. So on average, it takes me 4.32 guesses for me to win the Wordle.